छोटे कल की क्लास में हमने मास वॉल्यूम रिलेशनशिप स्टार्ट किया था और आपको बताया था कि बेसिक मास वॉल्यूम रिलेशनशिप के जो न्यूमेरिकल हैं वो बहुत इजी हैं। ठीक है भाई। एक और न्यूमेरिकल हम देख रहे हैं। द कंपाउंड कैल्शियम कार्बोनेट breaks into calcium oxide and carbon dioxide as calculate the mass of calcium oxide and volume of carbon dioxide produced at STP by 300 grams of कैल्शियम कार्बोनेट। अब भाई इस क्वेश्चन में मास रिलेशनशिप भी है और मास वॉल्यूम रिलेशनशिप भी है। कह रहे हैं कि भाई कैल्शियम कार्बोनेट ब्रेक होता है कैल्शियम ऑक्साइड और कार्बन डाइऑक्साइड में इस तरह। अब सवाल यह है कि अगर कह रहे हैं कैलकुलेट द मास ऑफ कैल्शियम ऑक्साइड एंड वॉल्यूम ऑफ कार्बन डाइऑक्साइड प्रोड्यूस्ड एट एसटीपी बाय 300 ग्राम्स ऑफ कैल्शियम कार्बोनेट। बेटा कैल्शियम कार्बोनेट का आपको जो अमाउंट गिवन है 300 ग्राम्स, ऑब्वियसली बेटा ग्राम्स इज द यूनिट ऑफ मास, सो आपको गिवन कैल्शियम कार्बोनेट का मास है 300 ग्राम्स, रिक्वायर्ड कैल्शियम ऑक्साइड का मास और कार्बन डाइऑक्साइड का वॉल्यूम है। तो अब ये ऐसे न्यूमेरिकल भी आते हैं जिसमें बेटा एक ही न्यूमेरिकल में दोनों रिलेशन आपसे पूछे जा रहे हैं, मास मास रिलेशनशिप भी और मास वॉल्यूम भी। ठीक है ना। सो मास मास रिलेशनशिप में आप कैल्शियम कार्बोनेट के मास से कैल्शियम ऑक्साइड का मास फाइंड करोगे। अच्छा, कार्बन डाइऑक्साइड का वॉल्यूम फाइंड करना है। मैंने आपको बताया था कि आप देख लेना, सर्टेनली हो सकता है कि ये एक ट्रैप हो। अगर कंडीशन एसटीपी है so you can directly apply the mass volume relationship and calculate the volume of carbon dioxide from the mass of calcium carbonate. Condition STP is given, so it is the numerical of mass volume relationship as well. पहले हम डेटा बनाएंगे। We always mention the given value first. So what is the given value? 300 grams of calcium carbonate. Gram is the unit of mass. So the given value is the mass of calcium carbonate 300 grams. Now I have told you many times that whenever the mass of a substance is given or required, you have to calculate the molecular mass and mention it in the data. So the mass of calcium carbonate is given, so we are going to calculate its molecular mass now in the formula there is one atom of carbon, so the mass of carbon will be 1 into 12 plus 2 atoms of oxygen, so 2 into the atomic mass of oxygen is 16. So that will, sorry, oh, need to find out the mass of calcium carbonate. So in the formula, there is one atom of calcium. So 1 into the atomic mass of calcium is 40 plus one atom of carbon. So 1 into the atomic mass of calcium is 12 and 3 atoms of oxygen. So 3 into atomic mass of oxygen, that is 16. It will sum up to 100 AMU. Now we need to calculate the mass of calcium oxide. So its molecular mass should also be mentioned. So the molecular mass of calcium oxide 1 into 40 plus 1 into 16, that sums up to 56 AMU. Now tell me, do we need to calculate the molecular mass of carbon dioxide as well? Yes or no? Since we have to find out the volume of carbon dioxide, neither its mass is given nor required, so it is not needed. Now we are going to mention the required values. We have to calculate the mass of calcium oxide and the volume of carbon dioxide at STP. So now solution. We have to find the mass of calcium oxide in the first place. So we are going to give a heading, the mass of calcium oxide, and then we'll write the equation. Calcium carbonate decomposes into calcium oxide and carbon dioxide. I've always told you people that we can relate two substances at a time, not more than that. And among those two substances, one must be the given one and one must be the required one. The given substance is calcium carbonate and required are two. So we are going to relate them separately. First, we are going to relate the given calcium carbonate with the required calcium oxide. And what is the way to relate? You know, the coefficient of calcium carbonate in equation is 1. So we'll write 1 below it, followed by a bracket. And the coefficient of calcium oxide is also 1. So we'll write 1 followed by the bracket. Now you know that this is the mass-mass relationship, and we have to put the values of molecular masses in those brackets. Molecular mass of calcium carbonate is 100. So we are going to write 100 grams in the bracket of calcium carbonate. And the molecular mass of calcium oxide is 56. So we are going to write 56 grams in the bracket of calcium oxide. Now 1 into 100 grams is the molecule is the mass of calcium carbonate, and 1 into 56 grams is the mass of calcium oxide as given by the equation. In the next step, we always write the given one on the left hand side and the required one on the right hand side. So among these two, you know, calcium carbonate is given and calcium oxide is required. So 1 into 100 grams calcium carbonate should be written on the left hand side, and 1 into 56 grams calcium oxide should be written on the right hand side. Now these standard masses that are proposed by the equation tells us that from 100 grams of calcium carbonate, 56 grams of calcium oxide is produced. Okay, 100 grams of calcium carbonate produces 56 grams calcium oxide. You have to calculate the amount of calcium oxide prepared by the 300 grams of calcium carbonate. So first, we are going to find out the unit mass, means we are going to find out the amount of calcium oxide produced by 1 gram of calcium carbonate, and for this purpose we'll divide the value of left hand side on the both sides. What is the value on left hand side? 100. When we divide 100 on left hand side, so 100 upon 100 will be 1 gram calcium carbonate, and the right hand side will be 56 upon 100 grams calcium oxide. So the equation told us that 100 grams of calcium carbonate produces 56 grams calcium oxide, and we have found that 1 grams of calcium carbonate gives 56 upon 100 grams of calcium oxide. Now what is to be calculated? The given value is 300 grams. We have to find out the amount of calcium oxide produced by 300 grams of calcium carbonate, for which the given value is multiplied on the both sides. So the given value 300 will be multiplied on both sides. So 300 into 1 on the left hand side, it will become 300 grams of calcium carbonate, and on the right hand side 56 upon 100 into 300 grams calcium oxide. Now when you will solve the fraction on the right hand side, 56 upon 100 into 300, you will get the mass of calcium oxide that will be produced. The mass of calcium oxide will be 168 grams, probably. Calculate the value, beta, by using your calculators. Now we are going to find the volume of carbon dioxide produced at STP. Whenever the mass of a substance is given and volume of other substance is to be calculated, you always need to confirm whether the mass volume relationship will be applied or not. And what tells us that the application of mass volume relationship is possible or not? It's the STP. So the conditions are given and we can apply the mass volume relationship directly. So the equation, now we are going to relate calcium carbonate with carbon dioxide, since we can only relate two substance at a time, not more than that. Now what is the way to relate? You know, the coefficient of calcium carbonate is 1, so we'll write 1 below it followed by a bracket, and the coefficient of carbon dioxide is 1, so we'll write 1 followed by the bracket. Now what comes in these brackets, you know, in mass volume relationship, the substance whose mass is given, the mass of calcium carbonate is given, so we will put the value of molecular mass in this bracket, and the substance whose volume is required, we are going to put the value of molar gas volume 22.4 in its bracket. So in the bracket of calcium carbonate, I put the value of its molecular mass 100 grams, and in the bracket of carbon dioxide, I'll put the value of molar gas volume, that is 22.4 dm cube. Now in the next step, I'm going to write the given value on left hand side and the required value on right hand side, and you know the mass of calcium carbonate is given, so 1 into 100 grams calcium carbonate will be written on the left hand side, and 1 into 22.4 dm cube carbon dioxide will be written on the right hand side. Now this standard has been extracted from the equation, and this tells us that 100 grams calcium carbonate produces 22.4 dm cube carbon dioxide. We need to find the volume of carbon dioxide produced by 300 grams of calcium carbonate. So first we are going to find for one or unit. And what's the way? When you need to find for the unit or one, you will divide the value of left hand side on both sides. So the value on left hand side is 100. When we divide 100 on left hand side, so 100 upon 100, 1 gram CaCO3 on the left hand side, and 22.4 upon 100 dm cube carbon dioxide on right hand side. So equation told us that 100 gram calcium carbonate gave 22.4 dm cube carbon dioxide, and we have calculated that 1 gram calcium carbonate gives 22.4 upon 100 dm cube of carbon dioxide. Now you are asked to find the volume of carbon dioxide produced by 300 grams of calcium carbonate, for which you have to multiply the given value 300 on both sides. So when we multiply the value of 300 on left hand side, so 300 into 1, 300 grams calcium carbonate, and on the right hand side 22.4 upon 100 into 300 dm cube carbon dioxide. When you will solve the fraction on the right hand side, you will get the value of volume of carbon dioxide produced at STP by 300 grams of calcium carbonate, and the value must be 67.2 dm cube. So numericals can be of that type as well, in which both mass and mass volume relationship has been asked together. Is it clear, students? Okay. Now there are some numericals that seem to be of mass volume relationship, but they are not. This is the last class of questions that we are going to do, after which the numerical revision of chapter 1 will be finished and we'll move to chapter 2. Now listen carefully. There are no numericals in chapter number 3 and 4. We have to be focused on the revision of numerical of chapter 1, 2 and 5 because we have studied it quite earlier. That's why. So I'm keen to recall the numerical of chapter 1, 2 and 5. And as far as chapter 6 KC numerical, chapter 7 balancing equation is concerned, you people have done it recently. So if you want to revise that as well, you just let me know. Okay. Now this can also be carried out like a wish list of you people, means you can ask me whatever you want to revise and I will do it. It is better that I'm not revise or recall the things which you people do not want, rather the things in which you need help. It will be better. Okay. I'll take, actually I'm taking another numerical revision class of another batch of another coaching in which I am doing the revision of KC numerical. So if it is feasible, I will announce the timing and take the class of both together. But in that class, I'll be recalling the numerical of KC only. Okay. So I'll let you know the time. Now, look at this question. Find the volume of oxygen produced at 27 degrees centigrade and 1520 torr by 2450 grams of KClO3. The equation is 2 KClO3 decomposes into 2 KCl3O2. First of all, find the volume of oxygen, which means you have to calculate the volume of oxygen produced at 27 degrees centigrade and 1520 torr pressure by 2450 grams of KClO3. Now the value 2450 grams. Gram is the unit of mass. So it is the mass of KClO3, 2450 grams. Apparently, the numerical is somewhat like the mass volume thing. Since the mass of one substance is given and volume of other is required, it resembles the mass volume relationship, but it is not. Because the conditions are not STP, the temperature is not 0 degrees centigrade, The pressure is not 1 atmosphere or 760 torr. Obviously, it is not STP. And you must remember that the mass volume relationship is only applicable at STP. Now, the conditions are not STP, which means that the numerical does not follow mass volume relationship. Then what should be done? First, we have to find the mass of oxygen by applying the mass-mass relationship, because it does not require any specific conditions like STP. So first, we are going to find the mass of oxygen by the mass of KClO3, and obviously that requires the application of mass-mass relationship. After getting the value of mass, we'll apply PV is equal to nRT and then find the volume of oxygen. In this way, this numerical should be done. So first, data. Always observe the given value first. The given value is 2450 grams of KClO3. So you will write it mass of KClO3 2450 grams. The mass of KClO3 is 2450 grams. Now you know that the substance whose mass is given or the mass is required, we have to mention its molecular mass. So the molecular mass of KClO3. Now we have one atom of potassium. So 1 into 39. 39 is atomic mass. One atom of chlorine. So 1 into 35.5, which is the atomic mass of chlorine. And 3 atoms of oxygen. So 3 into 16, which is the atomic mass of oxygen. And it sums up to 122.5 AMU. Now the numerical is apparently like mass volume relationship, but it is not, and you are just not directly calculating the volume of oxygen. First, we have to find the mass of oxygen, for which you need to apply the mass relationship, for which the molecular mass of oxygen will also be required. So previously the one whose volume is to be calculated, we did not mention its molecular mass because it wasn't required there. But now, since we have to calculate the mass of oxygen, we'll also mention the molecular mass of oxygen. 2 into 16. In oxygen, there are 2 oxygen atoms combined together. So 2 into 16, which is the atomic mass of oxygen, 32 AMU. We have to find the volume of oxygen. This time we won't write the condition STP, but prior to it, we should mention the values of temperature and pressure, since it will be used. The temperature is given 27 degrees centigrade, which has to be converted in Kelvin by adding 273. It will become 300 Kelvin. The value of pressure is given 1520 torr, which should be converted into atmosphere, because whenever PV is equal to nRT is to be applied, pressure must be in atmosphere. So we are going to convert the torr pressure into atmosphere by dividing it with 760. You will get 2 atmosphere. We have to find the volume of oxygen represented by V. Now in the solution, we are going to mention the headings. That first we are calculating the mass of oxygen by applying the mass-mass relationship. Now here's the equation. 2 KClO3 gives 2 KCl 3O2. You know, we can relate two substances at a time. One should be given, another required. Here the given substance is KClO3, required is O2. KCl is neither given nor required. So it will be just written in the equation and you will totally ignore it after that. Now we are going to relate the two. The coefficient of KClO3 is 2. So we'll write 2 below it followed by a bracket. And the coefficient of oxygen is 3. So we will write 3 below it followed by a bracket. Since it is the mass-mass relationship, molecular masses will be put in the brackets. The molecular mass of KClO3 is 122.5 grams. And the molecular mass of oxygen is 32 grams. Now 2 into 122.5, 244, or 245 grams of KClO3, and 3 into 32, 96 grams of oxygen. In the next step, we are going to write the given one on left hand side and the required one on right hand side. So 2 into 122.5, 245 grams. KClO3 is written on the left hand side since it is the given one, and 3 into 32, 96 grams oxygen is written on the right hand side since it is the required one. Now these are the values proposed by equation, that 245 grams KClO3 gives 96 grams of oxygen. We need to find the amount of oxygen prepared by 2450 grams of KClO3, for which first the value of unit should be calculated. And how are we going to do it? By dividing the left hand side value on both sides. So the value on left hand side is 245. When we divide it with left hand side, so 245 upon 245 is 1 gram KClO3, and on the right hand side 96 upon 245 grams oxygen. So equation told us that 245 grams KClO3 gave 96 grams oxygen, and we have calculated that 1 gram KClO3 gives 96 upon 245 grams oxygen. Now we have to calculate for 2450, for which the given value will be applied, multiplied on both sides. So 2450 into 1, 2450 grams KClO3 on left hand side, and 96 upon 245 into 2450 grams oxygen. So when you calculate the fraction on right hand side, you will get the mass of oxygen, that will be 960 grams. So now we have the value of mass of oxygen. Now we have to do it quickly because only 3 minutes are left. Volume of oxygen. I told you that whenever the condition is not STP, the only way to find the volume is PV is equal to nRT. And you know N is moles, which is equal to mass in grams upon molecular mass. So what we have done, we have substituted N with M upon M. We have to calculate the volume. So formula will be rearranged. This pressure, which is being multiplied on the left hand side, goes into the denominator on right hand side. MRT upon PM. Small m is mass in grams of oxygen. Obviously, we are calculating the volume of oxygen. So all the values that we are going to put must be of oxygen. So the mass is 960. R is constant 0.0821. Temperature was 300 Kelvin. Pressure was 2 atmosphere. And molecular mass of oxygen 32. Tell me the answer. $369.45 DMQ. Okay, the meeting is going to end soon. The students who are asking for me for different queries, they can contact me on WhatsApp. And finally, I have to say something in Urdu because some of the students are complaining actually. बेटा एक रीजन है जिसकी वजह से मैं कर रहा हूँ, मैं आपको बताऊंगा. आपको समझ नहीं आया तो इंशाल्लाह इसको मैं एक्सप्लेन कर दूंगा जिस तरह से आपको समझ में आ जाए.